Hi there. This is week 6, lesson 2, alkyl halides. These are also known as halocarbons. What we're going to do here is we're going to use another substitution group. This time we're substituting in our halogens for our hydrogen. So say we have a methane, right? And we take one of those hydrogens away and substitute it with one of our halogens. So fluorine, chlorine, bromine, iodine, right? We'll put a Cl on there, right? And that is a alkyl halide. And that's it. It's a very stable compound. Here's an example here. You can put these. You've heard of the depletion of the ozone layer, right? Our chlorofluorocarbons, right? That's what we're talking about. So these things were used as refrigerants. They used them in aerosol cans. It's not allowed to do that anymore. And they're very stable. But the negative side effect is that in the upper atmosphere, it really depletes the ozone layer. And so they had to ban use of these things in aerosol cans because we were just releasing too much. If you look in your book, there was a section in your book, I copied it and put it right here. It's talking about how like Freon, and Freon is what they use in a refrigerator or refrigerant. It's I'm going to say a liquid and a gas because they're going to use it and they're going to compress it into a liquid. And when you compress something into a liquid, right, it gives back energy. And then they're going to evaporate it and it's going to take in energy, right? So what they're using is evaporation and condensing to absorb and release energy. And so they if they want to cool inside, they're going to take the heat and change the molecule into a gas, pump it outside, then condense it down, and it's going to give off that heat. So it's why your back of your air conditioner's hot, right? It's putting the heat outside. We can move heat. There's no such thing as moving cold. We can move heat. You move heat out of the refrigerator, it's cold inside. You can also use it as a heat pump, which you want to move heat into the house from the outside, and you can do that in the wintertime too, so it works both ways. Look over that stuff. I put some other facts about some of these halocarbons, and read over that. Okay, what we're going to do is we're going to name these. It's very similar to naming any of the things we've done so far. We do have a few different little names that we have to put in there. Fluoro for fluorine, chloro for chlorine, bromo, and iodo. And if there's multiples, we use di and tri. Okay, last time I got a little carried away and I think I named too many of these. There's not very many on these to name at all. I think I just have 5 here. We have 2 to draw and then 3 to name. So I'll tell you what, I'll draw one. I'll name one, I'll draw one. Okay, so we have trichloromethane. Trichloromethane. Chloroform, which is used extensively as a solvent and firmly employed as an anesthetic. And this is what you see on the movies where they put the napkin on their person's face and they pass out, right? So very dangerous. If you do have chloroform, don't do that to somebody, your friends, for think it's going to be funny because you could end up killing somebody. It is very dangerous. Anytime they put people under for surgery, it's risky, even from the professionals do it. Okay, so it's trichloromethane. So that just means that we have a methane molecule that 3 of the H's have been replaced with chlorines. All right, so I'll let you do the next one. It should be pretty easy. I'll name one of these. Let's see here. How about I name the middle one? I'm just randomly picking the middle one. So we have 4 carbons in a chain. And then we have a bromine off of one of those. So the first thing we need to do is name our number, right? 1, 2, 3, 4. Now, why did I pick that side? Because the Br is closer to that side, right? Okay, so 4 carbons is butane, right? There's no double bond or anything in there, so that's pretty simple. And then we have a bromide on the second, so it's going to be 2 bromo butane. Easy peasy. I don't think you'll have any problem with those. And we're going to move to the next section. Okay, our next section is ethers. Another thing they use as an anesthetic, right? They put people to sleep with ether. If you ever watched that one Batman movie where, was it Heath Ledger, is that his name, was the Joker, and then he blew up that hospital? Well, it's the ether in there. He turned on the oxygen and the ether together. That's what made the big explosion. Okay, so common use of ether. They're going to use it as a refrigerant also, and they're going to use it in surgery, and they're going to use it as a solvent. Another thing they do with it is they use it to start cars. So if you have like a diesel car and it won't start, they spray ether into it, and that ether will is very flammable and will help get the engine started. Okay, so most of you guys have smelled ether. If you work on cars, you know what I'm talking about. It kind of has, I don't know, the smell is strong. It says a pleasant smell. I don't know about the word pleasant used there. You know, it has a very distinct smell. If you know what ether smells, it doesn't smell like an alcohol. It definitely smells like some other chemical, right? So it has a very specific smell. Ethers are soluble in water, right? So that's just because it's pulled. Now look at this. Let's draw the generic. I have it right here. So the generic is going to be R, O in the middle, R. So remember that R is just the hydrocarbon. So we have a hydrocarbon on one. I'm just going to draw one up here, and I'm going to draw it and name it at the same time. So if I put 2 carbons on a chain on this side, I'm not going to put any hydrogens on right now, okay? And then I'm going to draw my oxygen in the middle, and then I'll tell you what, I'm going to do the same. I'm going to have 2 of them, right? And then there's 2 ethyls, right? That's diethyl ether. Diethyl, there's 2 ethyls, right? If you had one, it'd be methyl ethyl ether, right? So you're just naming the hydrocarbon chain on either side of this oxygen. And I'm not going to be picky on which one you put first. They're probably supposed to be alphabetically, but but you just name those 2 sections and just say ether after it. If they're both the same, you say di. Okay, so I pretty much showed you how to name those, so I think you should be able to name these 3. I have one drawn up there. So I'll let you do that and drawing them. Okay, let's look at the name. Dimethyl. Okay, dimethyl. Well, that just means we have a methyl on one side, methyl on the other. And I'm going to leave you the little one. It's not hard. You'll be able to do that one too. So name those also. And so that'll be 2 sections so far. Okay. And I check my time. All right. And our last section. Let's check it out. I tell you what, we're going to stop right there for the day. That wasn't very long, right? That way I'll have like 3 videos this week. They'll all be short, and this will get us through the last 2 sections. I just don't want to, use all my time there. So again, just go through these. There's no notes on these. Just name the compounds, right? Or draw and name the compounds. There's 3 here, right? 1, 2, 3. If you want to do it right on the paper, some people have been doing it with like an app that lets them draw on the Google Forms. If you have an iPad type thing, you can do that. Or if you just want to draw on a paper and write the names and just keep them in that order that we have them in, that'll be fine. All right, well, have a great day, and that should be the 2 lessons. We had alcohol. It's already up on the line. I'll send links to both of these tomorrow, and it's Sunday night. So tomorrow, and then we'll start our week number 6. All right, thank you.